This is 4.5 part 3, special cases of polynomials and factoring. So we had just finished off by defining a perfect square polynomial, or a trinomial. And a trinomial is a perfect square if its first term, a squared, is a perfect square, if its last term, b squared, is a perfect square, and if the middle term satisfies one of the following here. If the middle term is the square root of the first term multiplied by the square root of the last term times positive 2 if it's positive, or if it's negative, it's the square root of the first term times the square root of the last term multiplied by negative 2 if it's negative. So we're going to go and take a look if the following examples would be considered perfect square trinomials or not, and we'll explain why that is. So we'll start off with the first one here. We have x squared minus 14x plus 49. So first let's find what a is equal to. A is equal to 1. C is equal to 49. And if you take the square root of them, you'll see that they're nice whole numbers that were used to make them, so 1 and 7. So these are both perfect squares. These are perfect SQs, perfect squares. So that's satisfied. The first two conditions are satisfied. First term is a perfect square. Second term is a perfect square. Now what we need to do is take a look at our middle term over here. Is our middle term following one of the conditions in the last point here? Well, let's take a look. So we said the middle term is the square root of the first term times the square root of the last term. So let's do that first. So we have square root of the first term times square root of the last term, which is 49. And then multiplied by either 2 or negative 2. Negative 2 if it's negative. So multiplied by negative 2. And so that's going to be equal to square root of 1 is 1, times square root of 49 is 7, times negative 2. That's going to be negative 14. And look what we have here, negative 14. So all three conditions for this trinomial are met. So this is considered a perfect square trinomial. And because it's a perfect square trinomial, we can use a technique that will simplify perfect square trinomial factoring for us. And we'll see that in just a bit. Right now we want to know how to identify them to see if we actually have perfect square trinomials or not. So let's go and try this next example here. Determine if this is a perfect square trinomial. So x squared plus 12x plus 64. Let's identify our a first. So a is 1. And our c, our last term, is 64. And if you take the square roots of each one of them, you'll get whole numbers. Square root of 1 is 1. Square root of 64 is 8. So yes, these are considered perfect squares, PSQs, perfect squares. So the first two conditions are met. The first term and last term are perfect squares. But we need to see if the middle term is actually the square root of a times the square root of c times positive 2. It's positive in this case. So let's see if that's the case. Let's take the square root of 1, multiply it by the square root of 64, and then multiply that by 2. And so we get 1 times square root of 64 is 8, times 2 is equal to 16. Is that your middle term? Well, 16 is not equal to 12. Therefore, not a perfect square trinomial. So the first two conditions are met. First and last term were perfect squares. But that third condition of square root of a times square root of c times 2 did not work out. So that's why this is not considered a perfect square trinomial. So the next few examples go over factoring using the perfect square method. So what we're going to do is we're going to write out the steps for the perfect square method, and then afterwards we're going to go and try these examples with the perfect square method for factoring. So the first step is to check for perfect squares in the first and third terms. So in other words, in A and C. Our next step is going to be to check that the middle term is 2ab or negative 2ab, meaning 2 times the square root of a squared times the square root of b squared, which is a and b, or negative 2 times a and b. Our next step is going to be to create a set of brackets in the form like this. So just one set of brackets to the power of 2. Now we're doing this only if 1 and 2 checked out, only if we have a perfect square trinomial at this point. Then we're going to determine the square root of the first and third terms and place them in the brackets. Our last step is going to be to connect our answers with a positive or a negative, depending on the middle term. So let's take a look at what that all means. Let's go to an example together. So first, let's see if we have a perfect square. Let's get our drawing tool back here. Let's see if we have a perfect square trinomial. Perfect square for the first term, good. Perfect square for the second term, good. Is our middle term actually going to be negative 2ab? Well, let's see. So negative 2 times square root of 1 is 1, or AC rather, times square root of 49 is 7. And that's going to be negative 14. So this works out. This is a perfect square trinomial. So what this means is we are going to have one set of brackets. Square root of x squared is x. Square root of 49 is 7. Since our middle term here is negative, we're going to put a negative here. And don't forget to put that squared up here. So in reality, what this actually is this is another way to have done this. If you did this without you knowing it was a perfect square trinomial, you would have done this. You would have done two brackets, two numbers that when you add when you multiply them give you positive 49, and when you add them give you negative 14. That would have been x minus 7 and x minus 7, because minus 7 times minus 7 is 49, and minus 7 plus minus 7 is minus 14. But because they're both the same, x minus 7 and x minus 7, you can simply combine them together by saying this is x minus 7 squared. It's like saying it's x minus 7 times itself. So we checked if this was a perfect square trinomial, and then we simply found the square root of a and the last term here, which we call c as a constant. And then afterwards what we did was we made the brackets, put the square, and then connected it by a negative because of that negative in the middle there. Let's go over here to our second example. Let's see if it's a perfect square trinomial. So first term's a perfect square, second term is a perfect square. let's just take a look to see if this actually works out. So the middle term should be 2 times the square root of the first term here, 1, times the square root of the third term there, which was square root of 25 is 5. So that should be equal to 2 times 1 times 5, which is 10. So that works out. That means we have a 2ab over here, which works out. So we have a perfect square trinomial. So we can make our first set of brackets over here. And in our first set of brackets, we're going to put an x squared over here, because the square root of x squared is x. This is going to be squared here. The square root of 25 is 5. Now this time, instead of putting a minus in the middle, we're going to put a plus, because our sign over here is also a plus. So again, this is the same idea. If you didn't know that this was a perfect square trinomial, what you would have done instead is you would have done 2 sets of brackets, 2 numbers. Their product is 25. When you add them together, they give you 5. They give you 10. So that would have been 5 and 5. So 5 times 5 is 25. 5 plus 5 is 10. And you would have had this. And you would have noticed that these are the same identical brackets, so they're multiplied by each other. So what that means is you could have just written it as x plus 5 squared. Notice identifying that it's a perfect square polynomial or trinomial gives you a bit of a shortcut when it comes to doing this situation here. So let's try example 3. Example 3, again, it's one of those situations where you might start off by checking the first term, and you might be doing the square root of 128. And you'll notice if you do that, square root of 128, it's not a perfect square. So you might just say, I can't do it, it's not a perfect square, I might have to use a different method. But remember, always try factoring something out first. Here it looks like you can factor out a 2. If you factor out a 2, you get 64x squared plus 16x plus 1. And now it looks like you have a perfect square trinomial. If you look, square root of 64x squared, that's 8x, that works. Square root of 1, that's 1, that works. Let's just double check though to see if that middle term is actually 2ab. So we have to do 2 times square root of 64, which is 8, but I'll write that down after, times square root of 1. And it's positive 2 because our term is positive in there. That will give us 2 times 8 times 1, which gives us 16. So this actually satisfies all 3 conditions of perfect square trinomials, and it is 1. So now we can apply our rule. We can have 2, make 1 set of brackets with our squared there, and then find the square root of 64x squared, which is 8x, square root of 1, which is plus 1. We're putting a plus here because the middle term here is a plus as well. So again, you could have done this by factoring in the other methods. If you didn't know it was a perfect square trinomial, you would have ended up with 2 identical brackets, and you would have just ended up combining them together in the end. Don't forget to put your equal signs here to have proper communication and proper form. So let's try this one out over here. If you do the perfect square check, this looks like a perfect square here, good. So does this, good. Let's take a look if we have our 2ab, so 2 times square root of 49, which is 7, times square root of 9, which is 3. This will give us 2 times 21, which is 42. So that works out and checks out. So we have a nice perfect square trinomial here, so we can make 1 set of brackets. Take the square root of the first term, that's 7x. Take the square root of the second term, that's plus 3. Or that's 3, like that. This is a positive term here, so we put a plus there. And don't forget to put your squared here. And so if you had done this using the old methods we learned, you would have basically ended up with 7x plus 3 and 7x plus 3. And you would have found that since they're both identical, you could have just simplified it to this over here. So a perfect square trinomial really makes it a lot easier to factor if you can spot it immediately. Make sure you check them before you proceed with factoring. So what I would do is always see if you have a greatest common factor you can take out, check if you have a difference of squares, or check if you have a perfect square trinomial, and then proceed just to make your life a little bit easier. You can go and retry these as well as the math homework from the outline.